Triple product will be is equals to what? Determinant of this in the first row, second row and third row will be equals to 0. Find the vector equations of the plane passing through the points 1, 1, 1, S of 6, 4, minus 5 and T of 4, minus 2 and 3. For the Cartesian form, dear students, I am going to take, let the points of R, S and T. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learned equation of a plane passing through a given point perpendicular to that point. Now, in today's session, dear students, here we are having session number 9, chapter number 11 called 3D Geometry of your second PUC Mathematics. Now here, we'll be moving on to one more derivation which is very important for your examination purpose and will be asked for a 5 marker. Now here, the equation of a plane passing through 3 non-collinear points. The diagram takes like this. The 3 non-collinear points here, the given points are nothing but R and T in a plane, and then I am going to consider a point P on a plane. The explanation of the diagram takes place like this. Now here, let R, S and T be 3 non-collinear points on the plane with position vectors A vector, B vector and C vector respectively. The vectors R, S and RT are in the given plane. The vector, which is this one, R, S and then RT. R, S and then RT are in the given plane. Therefore, if it is RS and RT in the given plane, then we can have that, see, which will be is equals to, here we are having, according to the diagram, you can take it as OP will be is equals to, OP vector is equals to R vector. Similarly, you can have OS vector, OR vector will be is equals to, see here, A vector, and then OS vector will be is equals to, OS vector will be is equals to B vector, position vector, and then OT vector will be is equals to C vector. So all this explanation you have to write down. Now here, according to that, you can have R vector minus A vector dot the triple product we are going to have into RS vector cross RT vector. This one, RS vector cross RT vector will be is equals to 0. This is going to be known as a triple product. Now here we'll be having RS vector is given by, let me write it, RS vector is nothing but OS vector minus OR vector. So which is nothing but OS vector, you know already, which is B vector. So B vector minus OR vector is nothing but A vector. So OR vector is A vector. Similarly, you can have RT vector will be is equals to OT vector minus OR vector. Now, what is OT vector? OT vector is nothing but C vector. So C vector. Now, OR vector is nothing but A vector. Now, substituting this in the equation, you are getting R vector minus A vector dot product of RS vector is B vector minus A vector cross RT vector is nothing but C vector minus A vector. So, this is going to be known as the vector form. Okay. So, of a 3 non-collinear points. So, this is going to be known as the vector form. Okay. Now, you have to move on to the Cartesian form. For the Cartesian form, dear students, I am going to let the points of R, S and T having the coordinates x1, y1, z1, x2, y2, z2, x3, y3, z3 respectively. Now here for Cartesian form, let x1, y1, z1, x2, y2, z2 and x3, y3, z3 be the coordinates of the points R, T and S respectively. Therefore, what you can have, and then here I am taking let P of x, y, z be the point on a plane with the position vector OP vector is equals to R vector is equals to xi plus yj plus zk. So therefore A vector takes place. What is A vector? So A vector is nothing but what? x1i plus y1j plus z1k. Similarly, B vector is nothing but x2i plus y2j plus z2k, and then C vector will be x3i plus y3j plus z3k. Why? Because OR, OS and then OT. OR vector, OS vector and OT vector takes place like this: A vector, B vector and then C vector. So that I have written the equations of those vectors. Now, let me take the vector form. What is the vector form? So, by vector form, we know that. So, R vector minus A vector dot B vector minus A vector cross C vector minus A vector is equals to 0. Now, triple product will be is equals to what? Determinant of this in the first row, second row and third row will be equals to 0. That is what? A scalar triple product. So that we need to find out what is R vector minus A vector, B vector minus A vector and C vector minus A vector. First, let me find out what is R vector minus A vector. You know already R vector is xi plus yj plus zk. You can observe here, dear students. Similarly, A vector is x1i plus y1j plus z1k. Now, R vector minus A vector is by taking I common factor, x minus x1 into I, correct, plus y minus y1 into j plus z minus z1 into k. Right? Similarly, what is B vector minus A vector? Now, what is B vector minus A vector? Now, B vector minus A vector is here I as a common factor, x2 minus x1 into I, see, x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k. This is what? B vector minus A vector. Similarly, what is C vector minus A vector? So, which is nothing but See, C vector is x3i plus y3j plus z3k, and A vector is x1i plus y1j plus z1k minus that. So, x3 minus x1 into I plus y3 minus y1 into j plus z3 minus z1 into k. So, this is what r vector minus a vector, b vector minus a vector, c vector minus a vector. Now, scalar triple product of all this will be equal to what? A determinant will be equals to 0. Now, you can have, so the Cartesian form. So, the Cartesian form is given by Cartesian form is nothing but writing the first row as r vector minus a vector coefficient of ijk. What is the coefficient of ijk? X minus x1, y minus y1, z minus z1. So, which implies that determinant of x minus x1, y minus y1, z minus z1. Okay, and in the second row, writing b vector minus a vector, which is x2 minus x1, y2 minus y1 and z2 minus z1. So, x2 minus x1, y2 minus y1, z2 minus z1. Okay, and then in the third row, writing c vector minus a vector, which is x3 minus x1, y3 minus y1 and then z3 minus z1. So, this determinant will be equals to 0. This is going to be known as the Cartesian form. How easy, dear students. Here you have to remember both the vector form and the Cartesian form. Now, based on this, dear students, we'll be moving on to solving a problems. Now, what is the first problem they've asked? They've asked like this: find the vector equations of the plane passing through the points r of 2, 5, minus 3, s of minus 2, minus 3, minus 5, s of minus 2, minus 3, 5 and t of 5, 3 and then minus 3. So, what is the position vector? So, position vectors of r, s and t is given by which is OR vector will be a vector, which is nothing but 2i, this one, 2i plus 5j minus 3k. Similarly, OS vector. So, therefore, you can have the point of x1, y1, z1. So, therefore, x1, y1, z1 is given by the points of 2, 5, minus 3. Correct. So, what is OS vector? OS vector is nothing but B vector, which is minus 2i minus 3j, this one, plus 5k. So, what is x2, y2, z2 there? So, x2, y2, z2 is given by, what is that? Minus 2, minus 3, 5. Okay. Now, similarly, what is OT vector? Now, what is OT vector? OT vector is C vector, which is equals to 5i plus 3j minus 3k. So, what is then x3, y3, z3? Yes, your guessing is right. x3, y3, z3 points 5, 3 and minus 3. Now, let me write the vector equation or the vector form. Now, what is a vector form? So, vector form or the vector equation is given by r vector minus a vector dot b vector minus a vector cross c vector minus a vector equals to 0. Now, r vector minus a vector is what? A vector is 2i plus 5j minus 3k. Now, here minus is there. You have to minus. Along with that, you have to multiply with the minus sign. So, minus into plus is minus, minus into plus is minus, minus into minus is plus. So which will happen here, minus 2i minus 5j plus 3k dot b vector minus a vector. What is b vector? Here, minus a vector. See, minus 2i minus 2i, which is minus 4i, right? Similarly, minus 3j minus 5j, which is minus 8j. Similarly, 5k minus of minus is plus, 5k plus 3k, which is 8k. So plus 8k, which is a b vector minus a vector cross. What is c vector minus a vector? Simple here. 5i minus 2i, which is 3i. So 3i. Again 3j minus 5j. 3j minus 5j is minus 2j. So minus 2j. Similarly, minus 3k minus of minus 3k, which is plus 3k. So minus 3k plus 3k will get cancelled. It is 0. No need to write. You can multiply as it is. If you want, you can write it 0k. Now which will be equals to 0. So this is going to be known as the vector equation. Now we will be moving on to solving Cartesian form. Now what is a Cartesian form? Cartesian form is given by x minus x1, y minus y1, z minus z1. x2 minus x1, y2 minus y1, z2 minus z1. Third row, x3 minus x1, y3 minus y1, z3 minus z1, which will be equal to 0, which implies that now you can x minus x1. What is x minus x1? Which is given by, see, x minus x1 is 2. So x minus 2, x minus x1, which is x minus 2. Similarly, y minus y1, which is y minus 5. So y minus 5. And then z minus z1, which is z minus of minus is plus. So z plus 3. And then x2 minus x1. See, x2 minus x1, minus 2, which is minus 4. y2 minus y1, minus 3 minus 5, which is minus 8. z2 minus z1, 5 minus of minus 3, which is 8. Similarly, x3 minus x1, 5 minus 2 is 3. 3 minus 5 is minus 2. Minus 3 minus of minus 3 is plus 3, which is 0. So, if you expand this one, you are going to get it as, which is equals to 0. Now, let me expand this one. So, first, by leaving the first column, first row, x minus 2 into, see, minus 8 into 0 is 0, minus of minus is plus, 2 8s are 16. So, 0 minus 16 is nothing but what? Plus 16 is nothing but 16 only. So, 16 again. Here leaving the second column first row, so minus y minus 5 into, see, minus 4 into 0 is 0, minus 3 into 8, 8 3s are 24, 0 minus 24 is minus 24. So minus 24 plus, now leaving the third column first row, z plus 3 into, you can have, leaving the third column first row, minus 4 into 2. Minus 4 into minus 2, which is plus 8, minus, already one minus sign is there. So 8 3s are, which is 24. So 8 plus 24 gives you 32, right? So 32, which will be equals to 0. Now expand this. So 16x, 16 2s are 32. Here minus into minus is plus, 24y, minus into minus is plus, plus into minus is minus, 24 5s are, 5 4s are 20, 2 is carry over, 5 2s are 10, 10 plus 2 is nothing but 12. So 120, again 32z plus 3 2s are 6, 3 3s are 9 equals to 0. Right? Now you can have 16x plus 24y plus 32z. Now if you add all this will be equals to, so here you can add up these two, 120 plus 32 which is 152. 152 plus 96, it will be giving you, so minus 152 plus 96, it is nothing but minus 56 equals to 0. This is going to be known as the equation in Cartesian form. That's it. Now you come to know how to expand this one. Now we'll be moving on to the next problem, dears. Find the vector equations of the plane passing through the points 1, 1, 1, S of 6, 4, minus 5 and T of 4, minus 2 and 3. Here they have asked only the vector equation, not the Cartesian. Now Cartesian I have explained in the last problem. Similarly, you can try it out for this one also. Now we'll be writing whatever they have given. Now they have given position vectors of R, S and T given by OR vector, which is nothing but A vector, which is 1 into I is I plus 1 into J is J plus 1 into K is K. Similarly, OS vector, which is nothing but B vector, which is given by 6 into I plus 4 into J minus 5 into K. Similarly, OT vector, which is nothing but C vector, which is 4 into I minus 2 into J plus 3 into K. Now, what is a vector form? So, vector form is given by, vector form, which is given by R vector minus A vector dot cross product of B vector minus A vector cross C vector minus A vector equal to 0. Now, what is R vector minus A vector? So, here R vector minus of this, all it will come minus because everything you are having in plus symbol. So, R vector minus I minus J minus K. Similarly, B vector minus A vector is 6I minus I, which is 5I plus 4J minus J is nothing but 3J, again minus 5K minus K, which is minus 6K. This is B vector minus A vector, cross product of C vector minus A vector, 4I minus I, 3I, minus 2J minus J minus 3J, again 3K minus K, which is 2K. So, which will be equals to 0. This is going to be known as the vector form. If you want, you can try it out for Cartesian form by writing the 3 rows. Determinant will be equals to 0. Right? Now, we'll be moving on to the next problem. Here also they have asked, find the vector equations of the plane passing through the point R1, 1, 0, S of 1, 2, 1, T of 2, 2, minus 1. Now, here what they have given? Position vectors of R, S and T given by OR vector, which is A vector, which is 1 into I plus 1 into J is J plus 0 into K is 0. Again, OS vector, which is nothing but B vector, 1 into I is I plus 2 into J plus 1 into K is K. Similarly, OT vector, which is nothing but C vector, which is 2 into I plus 2 into J minus 1 into K. Now, what is a vector form? So, vector form is given by, R vector minus A vector dot cross product of B vector minus A vector cross C vector minus A vector equals to 0. Now, what is R vector? As it is, minus A vector is minus I minus J along with the minus sign I minus j dot product of b vector minus a vector. I minus I, which is 0. Again 2j minus j, which is j, right? So j, k minus 0. K minus 0 is k. So plus k. This is what? B minus A cross C minus A. Now C vector minus A vector, 2I minus I, which is I. Again 2j minus j, which is j. Again minus k minus 0. Minus k minus 0 is minus k only, is equals to 0. This is going to be known as the vector form or the vector equation of the given problem. I hope you understood all the problems, how to solve it in the vector equation and how to solve it in the Cartesian form. If you want these two problems, you can try it out in the Cartesian form. Okay dear students, in the next session, we'll be moving on to one more concept of the 3D geometry based on that problem. So until then dear students, keep watching. Have a nice day. Thank you.